Okay, so as we've been doing, finding a lot of zeros and stuff like that, we're going to continue to do that. Let's take a look at this polynomial here. Unfortunately, I can't see any factors here. I can't see if I try to group the first two and last two, or try to group 2 and 1, or 3 and 1, and 1 and I can't figure out how to do that. So the other way to do that, to find the zeros, is, we could try a whole bunch of numbers with synthetic division and see which ones work. However, that's way too much. So let's look at some kind of way of looking at it. And there are some ways to get only the possible ones, and that's where we use this form P over Q, where P is a factor of the constant, Q is a factor of the leading coefficient. So what does that mean for this one up here? Well, our constant is 6. Don't worry about the positive or the plus or minus. So that means our P values are factors of 6. 1, 2, 3, and 6. Our Q is a factor of leading coefficient. So again, leading coefficient, highest power. What's a coefficient 2? So what are the factors of 2? 1 and 2. So the possible rational zeros, these are going to be the only numbers we could check, is going to be, now I like, again, do it organized. I like to go through each one of these over the first Q, then to the second Q, and third. So I'll go 1 over 1. Now it's also plus or minus, because we don't know. Think about this, negative 6. Is it a positive 1 times a negative 6, or negative 1 times a positive 6, or vice, whatever? We don't know. So we got 1 and 1, 2 over 1, plus or minus 3 over 1, plus or minus 6 over 1, and then 1 over 2, 2 over 2, plus or minus 3 over 2, plus or minus 6 over 2. Yeah, I know, if we look at these, some of these, like this one and this one, are duplicates. That's only because those two numbers have a common factor. Don't worry about them in the list. Leave them that way. Be done. When we actually use them, we don't have to worry about them again. These are the numbers we're going to use. Now it's a whole lot less than what we were thinking of doing before. Okay. Now, we think back to what we do with plain old regular numbers kind of thing. So if we were looking at a number like 735, and we want to factor that, yeah, we can keep looking at a whole bunch of numbers, try a whole bunch. Now we know there is one number right off the top, 5. It ends in 5, so we could factor that out and then say, okay, so that would be 5 times 147. Now when we start looking at other numbers, what else can we factor? What other factors? We don't go back to 135. We go to the smaller number, the 147, and look at tricks. Or not tricks, but ways we know we can factor. Like these numbers. 1 plus 4 plus 7. Since it's 12, 12 is divisible by 3, so is 147. And we get 49. Finally we get to a number we know what we can factor. So that's what we're trying to do here. When we find the zeros, we're trying to find like these factors kind of thing. And by doing that, we got to look at numbers we know. Well, these are the ones we know. So let's go back to getting the possible numbers we could use. So what do? We list them out. So what are the factors that lead the constant? factors of the leading coefficient. Now, sometimes I'll write it like this over here. So 1, 2, 4. You don't have to write 2 twice. And now, P over Q. Each one of these over each one of these. Again, how you do it doesn't matter, but I would suggest being organized. 1 over 1, 5 over 1. Again, we know that's 1 and 5. That'll work. Plus or minus 1 over 2, 5 over 2. Notice by doing it organized, and then 5 over. I know I'm not going to duplicate anything nor leave something out. So each one of these, 1 over 1, then over 2, then over 4. So there's really not that many numbers. 1, 2, 3, 4, 5, 6, plus or minus, so 12. We just have to try 12 numbers to get the possible rational ones. Okay? As opposed to how many, infinitely many, we could really have. So let's go ahead and do the same thing here. What are the values for P? What are the factors of 12? I've known to do this too. Right about that way. So write the pairs 1, 8, 2 to 4, and nothing else in between. So each one of these over each one of these. This is where maybe, so 2 over 1, 3 over 1, all pluses or minuses. You can say, if I see some duplicates, do I have to include them? No. But if you don't see them, you may as well include them. So now, each one of those over 2. There's a duplicate. There's a duplicate. Another one. And another one. So it means these duplicates, we're not going to actually physically try. But in our list, we may just want to include them. So plus or minus 1 over 4, 2 over 4, another duplicate, another duplicate, oops, over 4. And then same thing with 8. Or so plus or minus 1 over 8, 2 over 8, 3 over 8, 4 over 8, 6 over 8, 12 over 8. Ugh. See, that's why we like taking out common factors first. It makes this stuff shorter. Alrighty, so let's go back to the original question and example 1. Going way back up here. What are the zeros? Well, we're going to try these numbers. I'm going to relist them again. Down here off to the side. Plus or minus 1, 2. I lost my thought. 3, 6. 3, 6. 1/2. Then we had a duplicate of 2 over 2, 3 over 2, 6 over 2, came back to 3. So those are the ones that are unique. And what do? We just see which ones are zeros. So we need 1 0. So we need to get 2x cubed plus, should I have kept it 3x squared? And now, how am I going to do it quick? Synthetically. So let's try 1. Why 1? Why not? Is 1 0? So multiply, bring the 2 down, multiply, add. Multiply, add. Multiply, not a 0. Let's try 2. Bring the 2 down, multiply, add. Multiply, add. Multiply, add. We got a 0. So x equal 2 is a 0. Now, just like what we did with that number, we didn't go back to the original try to find the other ones. We used the smaller one, the depressed value. So again, we're going to do that here. What do we have? Started with x cubed. So now we have 2x squared plus 7x plus 3. That's equal to 0. Factorable? I think so. Because if I go, let's see here, 2 pluses, 2 times 3, 6, 1, 7x, crowd goes wild. So here we got -1/2, -3. So those are the zeros. So really our idea is anytime with these we try to get to a quadratic, an x squared, we know how to solve those. Factor, or if we can't see the factoring, always use the quadratic formula. Okay, we'll work on the other side in part 2.